This is a story about visualizing dynamic systems that I've always called energy and information systems. And I'm going to use some examples of this as it relates to a marble rolling down a ramp and later data flowing through a gigantic mainframe system. And then also through the ideas of business visualization. And it all works the same way. So I'll start this by describing what I imagine when I imagine systems. And I learned this from watching things move around me and taking snapshots of the things that are moving in different positions and comparing them to each other and noting rates of proportional change, how quickly things are moving. And I would also listen to things and listen to the different sounds they made in different positions and as it related to the rates of change of velocity. And this ability, this modeling ability, was useful because I could see these relationships in models, visual spatial models that were color coded at snapshots in time. And I'm going to describe the models because what it is a model of cognition, or at least my cognition, which is a model of a way to visualize in a proportional way the relationships between everything in a system at a snapshot in time, and then stringing those snapshots together to create a dynamic model of the system. And that's an energy and information system. And so I'll describe this through a marble rolling down a ramp. And I have some diagrams of this from, who knows, 20 years ago that I'll be showing on this page. And here we go. So if you imagine a marble at the top of a ramp, that marble has a diameter, a size, and let's call that the visual weight. That's the visual weight of the marble. And if you had a marble that had a diameter that was twice as big, the visual weight would be 2 times the visual weight of the original marble. And that's a way to know things in relative proportional ways without measuring them, like on a scale. So one of the reasons I standardize on a particular size marble is it always did the same thing. And I had 3 different size marbles at one point, but I learned just to use one because it always did the same thing. And if I mixed them up, they did different things. They would knock over a different number of dominoes from the same height. And I wanted to control the variables so that I could build the models in my mind in a way that was sort of, linear and not random, better way to say it. So I would control the variables by using a marble with the same visual weight in every experiment. And I would put a marble at the top of the ramp. And at the bottom of this ramp was a Hot Wheels track for cars. But at the bottom of the ramp, right when the curve stopped, when it got flat, I would lay down dominoes. And I would see how many dominoes got knocked over from different heights on this ramp. And I used a yardstick to keep the ramp flat. And I would put it in my drawers in my dresser to get the heights. So it was always the same. It was always the first drawer, the second drawer, or the third drawer, and it was always the same lane. And I would sometimes play with it. My room was bigger than that, so I would, stretch it out. But point of it is at some point I systematized the thing and standardized on this experiment that I was doing. And so now I could imagine a marble at the top of this ramp, and I could see that let's say there were 10 dominoes at the end of the ramp that hadn't been knocked over yet. And I would let the marble go. And in my mind, I would be taking snapshots of it in position 1, which was at the top of the ramp, and maybe a 1/10 of a second later, and a 1/10 of a second later, and a 1/10 of a second later. And maybe not, like maybe I just made that up and think that that's what it was, but I could interpolate, okay, between these things. So even if it was 1 second later, I could go backwards to see where it would have been before and the increments in between and fill them in quickly, seemingly instantly to me, and have these snapshots as it went down the ramp. And on the length of the ramp that I had, I might have 10 snapshots in my mind by the time they hit the dominoes. And the reason I started using ramps is because I couldn't do it fast enough when I dropped something. And it also wasn't repeatable. So I could slow down the motion of the marble by putting it on a ramp with different inclination, different height, and take these snapshots. And I would also listen to the sound of the marble in the different positions that it was in. And I could see the, call it the intensity, the volume of the sound in a spatial model, like a circle that's getting bigger. And the rate that that circle gets bigger in my mind is proportional to the velocity. So it was a way to watch the marble accelerate, but also hear it accelerate and compare the sound that I was hearing, getting louder and changing pitch, to the velocity, and see if those things were related. And I knew that the sound that I was hearing was related in some way to the marble losing energy. And that was friction. So what I was hearing and seeing was the energy loss due to friction in a scale model. Because I know that a marble on a flat surface that isn't rolling doesn't make any sound. And the faster it's going, the louder it gets, at least in the increments that I had in this experiment. So you know, I didn't have the idea of terminal velocity, like that there would be like a maximum speed of this. But I did these experiments, and so what I would see is a visual representation of the visual weight of a marble, the map of the velocity as it related to the sound that was getting accelerating. And I would count the number of dominoes that got knocked over at the end of the ramp as a function of these things. So the size of the marble was constant. The circle that represented the velocity, which I could hear and see, was getting bigger. And I also used crayons that I laid out on the floor in a specific order. So I knew which crayon the marble was at as a function of the visual representation of the velocity and the sound that I was hearing at these snapshots in time. So I could keep track of where it was and when it was. And what this is a model of, going back to cognition, is 6 things. And the first thing is, what am I looking at? And that's a marble. And the second thing is how many are there? And there's only one. But another component of that is how much is it, which was the visual weight of it. It's a marble of a certain size. So that's a two for one thing. It's a marble and it has a size. So that's an object and the value of the object. And the next one is where is it? And based on where it was in relationship to these crayons, I knew where it was at a snapshot in time. And when is it? And I said in an earlier video, I used to practice with time with the stopwatch. And I would practice starting and stopping the stopwatch at 2 seconds, 5 seconds, 10 seconds, 30 seconds, and a minute, 60 seconds, and then 300 seconds. And I would practice start, stop, start, stop. And I was trying to improve my accuracy. And I would visualize time as an expanding bubble. And I was good at it after a while, doing this hundreds of times, maybe thousands of times. And I could keep track of time very accurately, the passage of time, how long things took. And I was accurate at 300 seconds, plus or minus 2 seconds, reliably, and better, closer in, within the tolerances of reflexes. And but I would try to bake that in too, because I kind of knew like what the delay was. So I was good at time, so I knew when it was. So at this point, I knew what it was, how much of it there was, which is mass, where it was, when it was, how. How's always a flow chart. And every how question can be answered with a flow chart. And the flow chart of this was the ramp. That's how. And if the curvature of the ramp changed, then the how was different. So the ramp could be curvy, like wavy, and that's a different how, because the flow chart would go here and then there and then there and then there and then there. But I made it as straight as I could. But I knew that was how. And why. Why questions can always be answered in a multivariable plot. And there's an infinite number of whys for everything. You can always ask another why, always. But what I learned about why questions is to rank them, rank the variables. So if there's a why question and there's 10 possible reasons why that you can come up with, if you rank them 1 to 10 in terms of importance, what's important to you, what you think is the most important, and you plot the top two next on a graph next to each other, sort of like from your orientation this way. Can't do the cameras backwards. Okay, so anyway, this way. Then what you end up with is a plot where in the upper right hand corner is the most important reason why. And I didn't really know why back then about mass and gravity interacting to create a situation where a marble rolls downhill. I didn't know why, but I knew it was missing. And and I could see this in these visual models, not in the words I'm describing them with now, but in a model of this, all related at different snapshots in time, color coded. And I have a picture of this on my wall. And this way of knowing something that's moving is comprehensive because there's nothing else to know about the thing. Now that is cognition. That's not wisdom. So that's knowing a thing completely at an instant in time, and then sampling that thing at the instant over many snapshots to build up an intuitive sense of what's going to happen next. Because if you string these snapshots together, you create a dynamic model, an energy and information system. And based on that, you can pretty much know where the marble's going to be later. And the system is made up of energy, which is the thing that is moving and the mass of the thing that is moving. Information, which are things that you measure about it, and rules, which are the things that convert it from energy into information. And in this case, the energy is a marble of a certain size. And the information is where basically everything is in a snapshot in time, which has a where and a when. Where is it and when is it? And the information in this case could be the sound of the marble at that snapshot in time, a visual representation of what is happening, the what is happening. And the rules are why, which is the mass gravity interaction at that snapshot in time. And these things can be viewed together. And this way of conceptualizing the conversion of energy to information through rules is the basis for business visualization. And also a couple other optimizations I did in my life in terms of money and also in terms of IT architectures, moving data around quickly, optimizing, understanding how the data flows through this way. And those things were advantageous. And so I guess I want to say about this is that the ability to conceptualize dynamic systems, nonlinear systems that are related in visual spatial models that are proportional and to scale and sequenced in time has been useful. And when I was a kid, I wanted to explain this and use this idea to launch a global eco project to do something good for nature. And it's taken me a lifetime to be able to translate this and explain it in those words, because I see it in a place in my mind that's completely disconnected from language. And it's taken me since I was 10. So I don't know, 42 years now, almost 43 years to translate this idea to these words and create models and prove it in real life, business things, optimizations I've done. And I'm happy I'm at the part where I can share it.